Hello everybody. In this video I'll be looking at a problem from JEE Main Exam Paper 1, and it is a trigonometric equation, and it is all sorts of nasty. So the first thing I do whenever I have a trig equation that involves functions that are not sine or cosine, I rewrite them in terms of sine and cosine. And so if we do that, we get And so I just rewrote every single function in terms of sine and cosine. Now we notice that each denominator is either a sine or a cosine. So if we multiply everything by sine x cosine x, we will clear every single denominator. And what we get afterwards is square root of 3 sine x plus cosine x plus 2 times sine squared minus cosine squared. Now this looks like a fairly easy identity. I mean, it's sort of close to sine squared x plus cosine squared x, which would be 1, but in fact this is just equal to negative cosine of 2x. And so since it's negative, I'm going to move it to the other side of the equation. So we'll have 2 cosine of 2x on this side of the equation. As for this part, square root of 3 sine x plus cosine x, I'm going to use something called the R method. And if you don't know what that is, I'll have links about it in the description. But using the R method, we can transform this sum into a single trig function, which would be 2 cosine of x minus pi over 3. And we can just get rid of the 2's on both sides. And so now we have something in an equation of the form cosine of A is equal to cosine of B. And whenever you have that, we know that A is equal to 2 pi n plus or minus B. Because cosine is an even function, so we have this plus or minus here. And the period of cosine is 2 pi, so if we have a integer multiple of 2 pi, then this will be all of the forms of the solutions. So we have two cases. In case 1 will be the positive, and case 2 will be the negative. So I'll write positive over here and negative over here. So the first case is x minus pi over 3 equals 2 pi n plus 2x. And the second case is x minus pi over 3 equals 2 pi n minus 2x. So we can just tackle these situations individually. In each case, we want to isolate x. So in this, we can just subtract x on both sides and then subtract 2 pi n, and we get that x is equal to negative pi over 3 minus 2 pi n. Here, we can use the information that x, where we know the domain of x, and so we can create an inequality involving n. And after simplifying, we will get that n is less than negative 2/3, and it is greater than 1/3. And n, as we said, it is defined as a positive integer, so that 2 pi n coincides with the period of the cosine. Or not just a positive integer, but an integer. And so the only integer in this region is n equals 0. And so we can plug that in here, where we can plug in n, and we get that our solution is x is equal to negative pi over 3. And we can basically do the same analysis on this side. We isolate x and then create an inequality. And when we do so, we get that the values of x are pi over 9, negative 5 pi over 9, and 7 pi over 9. So I'm not showing the work because it's the exact same method as here. Just get x, isolate x, and plug it into the inequality and get an inequality for n, we will find that n is either -1, 0, or 1, and each of those n values corresponds to a solution here. Now, the problem is asking for the sum of all the distinct solutions, and so that would be these four x values here. The sum of these three is 7 plus 1 minus 5 is 3 pi over 9. 3 pi over 9 is the same thing as pi over 3. So pi over 3 plus negative pi over 3 is just 0. So the final answer is C, 0. Thank you for watching, and I'll see you in my other videos.